Hi, today we're going to present our group project about Marrybrown in Raub. Let's go.
So for the first content, introduction. Marrybrown is Malaysian owned fast food chain that serve halal certified Malaysian and Western dishes. The branch that we chose as our project is at 65 Jalan Perdagangan 5, 27600 Raub District, Pahang. The operating time is at 9 am until 11 pm every day. The observation time for our project is 1 hour from 2 pm until 3 pm. The number of server is 2. Next, here is our service center building, customer and waiting line, and the server. This video contains our project's observation. From what we got, the number of customers arrival are around 20 people per hour. Meanwhile, the service took around 2 minutes.
Next, let's look at the arrival characteristic. The size of the calling population is considered infinite, meaning there's an unlimited pool of potential customers. Pattern of arrival at the system follow a random pattern and adhere to Poisson distribution. For example, we assume an arrival rate of 20 customers per hour. Additionally, behavior of the arrival axis is customers are considered patient, meaning they are willing to wait in the line for service.
Next, the waiting line characteristic. There are two. The first one is the length of a line. Based on our observation, the line at Marrybrown has an unlimited length because there's no specific cap on the number of customers who can wait in the line. This could be due to ample space around the restaurant or the flexibility in managing customers. Basically, the line can continue to grow as more people arrive as long as the restaurant can manage the flow. Second, the queue disciplines. For Marrybrown, they use priority-based order. Customers' order are prioritized based on predefined rules. For example, for customers that order only side dishes, the time prepared are faster than complex meal combos.
Now, let's look at the service facility characteristic. For the configuration of the system in Marrybrown, the number of channels, we use multi-channel system, which are the counter service for customer to making order, where S equal to 2. Secondly, for the number of paces, in this case study is single pace system, where the customer will receive the service from one station. Thirdly, the number of waiting line is single line. Now, let's move to the pattern of service time. We use Poisson distribution as our pattern where the mu equal to 30 customers per hour. So this is the basic queuing system configuration of Marrybrown Raub. They use multi-channel single-phase system. Firstly, the customer will arrive and will queue in the waiting line before making their order at the self-service kiosk or the counter. Next, the customer will be served by the service facility, which is, in this case, is the cashier, where the food will be taken and all the food order will be served on that time. Lastly, the customer will exit Marrybrown after complete their order.
Now, let's move on to the queuing model. For lambda, this is number of customers arriving in 1 hour. Lambda is equal to 20. Mu is number of customer service in 1 hour is mu is equal to 30 and server is equal to 2. 1. The utilization factor. Rho equal to lambda over S or server multiple to mu equal to 20 over 2 multiple to 30 and we equal 0.3333. For the probability that there are 0 customer or unit in the system, PO equal to 1 over submission 1 over n factorial multiple to lambda over mu power of n plus 1 over s factorial multiple lambda over mu power of s multiple 1 over 1 minus rho. So we enter the value in the formula and we got 1 over in a bracket 1 plus 2 over 3 close the bracket plus 2 over 9 multiplied to 1.4999 and we got 1 over 2 or 0.5. Next, the average number of customers in the queue is equal to LQ. LQ is equal to rho multiplied to lambda over mu power of s multiplied to PO over s factorial multiplied to 1 minus rho power of 2. And we enter the value 0.3333 multiple 20 over 30 power of 2 multiple to 0.5 over 2 factorial multiple to 1 minus 0.3333 power of 2. And we got 0.08332 when we assume as 0 customer. For the average number of customer in the system, L equal to LQ plus lambda over mu. So the value is 0.08332 plus 20 over 30 and we got 0.75 and we assume it's 1 customer. For the average time a customer in system, which is WQ is equal to LQ over lambda. So 0.08332 over 20 and we got 0.004166 hours. For the average time a customer spend waiting in the queue, which is W is equal to L over lambda. So 0.75 over 220 and we got 3 over 80 or 0.0375 hours.
Now, we move to the result using POM-QM. POM-QM is a software used for production, operation management, quantitative method. Let's take a look at the result that we got. From the solution table, there are 5 parameters. The first one, the value average server utilization is 0.3. The second one, the value for average number in queue, LQ, is 0.08. The third one, the value for average number in system, L, is 0.75. The fourth one, the value for average time in queue, WQ, is 0.25 minutes. The last one, the value for average time in the system W is 0.04 hours. So, the last table that we got is the probability that there are 0 customers or units in the system. The value is 0.5.
For conclusion, there's 2 things that we can conclude. First, the number of the server provided are adequate because the customer are being served with service rate more than arrival rate of customer. Because of that, customer will be happy because they only need to wait for 2 minutes. So much things we learned when conducted this group project. First one is if the arrival rate are lower than the service rate, it means that the service are quick and the server is adequate enough to cater the number of customers. And using queuing theory to study the waiting line, it helps to understand the company better by computing its operating characteristic. This gives an insight of the company to further ensure the company can operate it best.